Okay, if you did question E, you were nice, you wrote it out twice and then you expanded. The 2x multiplies the 2x and the minus 5 to get 4x squared minus 10x, and then the minus 5 multiplies the 2x minus 5 to get the minus 10x plus 25. And then when we collect like terms, we have a minus 10x here and another minus 10x to collect to make minus 20x. So our final answer is 4x squared minus 20x plus 25. Okay, now this one I had suggested that you multiply your binomial first and keep that 3 on the outside. So 2x times the x would be 2x squared. A minus 2 times, the 2x times the minus 8 would be minus 16 with an x. A plus 1 multiplying x would be plus 1x, or just plus x. A plus 1 times a minus 8 would be minus 8. Okay, now we can collect inside those brackets to get 2x squared, minus 15x's, and then minus 8. And then that 3 can now multiply through the bracket to get 6x squared, minus 45x. And then 3 times minus 8 would be minus 24. Okay, and then we're done that one. Now with this, order of operation applies. I'm going to have to multiply these two brackets together because there's nothing inside the bracket to simplify first. So Bedmish says brackets first, but there's nothing inside to do first. There are no exponents to worry about, so then multiplication takes care of our next step. So this first part we should get 8x, a minus 2 times 3 would be, so I've done this, I'm doing this one now, 2 times 3 would be 6 with an x and a squared on that one because we have x times x. Then we're going to have minus 5 multiplying through the bracket. That would be a minus 20 when it multiplies the 4. And then a minus and a minus will be plus. 5 times 3 is 15 with an x. And then it's done its multiplication, and then we want to take away the 2 times the product of that bracket, so it'll be a takeaway. 2 times 3 is 6 with an x squared, and then we're going to be taking away 2x times positive 7, which would be take away 14x. And then looking for like terms, I'm going to write in descending powers of x. I'm going to look for my x squareds first, which is minus 6x squared, and another minus 6x squared to make a minus 12x squared. So descending powers of x first. Then we have a plus 8x, and a plus 15x, and a minus 14x. So plus 15x and the minus 14x would result in just positive 1x, plus the 8x would result in plus 9x. And then there's only one constant term, and that's the minus 20. So there's our standard form, descending powers. Now when we do the last one, we've got the two tricky things that happened in part E and part F. I'm going to keep my 2 outside. I'm going to multiply through this bracket. Okay, so I should get 5x squared, plus 1x, or just plus x works, a minus 20x, and then a minus 4. That's the end of that multiplication. Now I've run out of room, so I'm going to write this down below, and then I'm going to have takeaway, and I would be nice and write that out twice, x minus 2 times x minus 2. So I've got to take away that answer I get when I multiply the x minus 2 with the x minus 2. Alright, so I'm going to get 2, and then that bracket would simplify to be 5x squared minus 19x minus 4. That's a 19, not a plus. And then 4, and then we're going to take away, if I expand x with x, I get x squared, a minus 2x, a minus 2x, and a plus 4. Close that bracket. I'm going to multiply the 2 through the bracket and get 10x squared. 2 groups of 19 would be 38, so minus 38x, minus 2 groups of 4 would be minus 8. And then we're going to take away, in brackets we have x squared, minus 4x, and then plus 4. So I have to take away all of that. That means it's like multiplying minus 1 through that bracket. Okay, so we're going to keep that to the end. We're going to do that. And let me see if I can move this up. Yep, that did work. Okay, so that's going to now equal 10x squared minus 38x minus 8, and then a minus x squared, a plus 4x, and a minus 4. And now collecting like terms, 10x squared minus x squared would be 9x squared, minus 38 x's, but then add 4 x's would be minus 34 x's. And then we have a minus 8 and a minus 4, which would be minus 12. So hopefully that makes sense for that part, and we'll look at the next question. Okay, we want to show using algebra that these three functions, so this is one format, this is our second format, and this is our third one, they all represent the same parabola. So the last one, do you notice that that one is in standard form? It's already been expanded and simplified. Our easiest point, point of entry at this point in time would be to take what we have for that first equation and see if we can expand and simplify. Once we do that, we're hoping it actually ends up to be equal to version 3 of that parabola. And this one I would do the same thing with. I would expand and simplify, and hopefully that will end up being the same as version 3. So I really only need to play with version 1 and version 2, equation 1 and equation 2, and see if they will expand and simplify to be equation 3. If you haven't done that, if you were stuck and didn't know what to do, try that now, and then you can check. Okay, if I look at equation number 1, I have y equals 2 bracket x minus 6 all squared, and then minus 8. So I'm going to be nice and write that x minus 6 out twice. X minus 6 times x minus 6. And then I have this extra minus 8 on the end, which is the last thing of bedmess that I need to do. I'm going to take that x minus 6 and multiply by the x minus 6. And then afterwards I'll multiply by the 2. So x times x would be x squared. A minus 6 times the x is minus 6. A minus 6 times an x is minus 6 with an x each time. And then minus 6 times minus 6 would be plus 36. And then minus 8. We would have 2. We're going to get x squared. A minus 6x and a minus 6x is minus 12x's. Plus 36. Minus 8. Run through that. The 2 multiplies now through that bracket. And when I do, I drop my brackets. So we get 2x squared minus 24x. Two groups of 36 would be 60, 72, plus 72 minus 8. 2x squared minus 20, 24x. And then if I put my plus 72 and then subtract 8, that would be 64. So plus 64 on that. So if I compare that now to equation number 3, yep, that's equal to equation number 3. So equation 1 does equal equation 3. If I put both of those in Desmos, I know that the graphs would land on top of each other. Now let's play with equation number 2. We've got 2, y equals 2 bracket x minus 4, and then an x minus 8. And then we get 2, and then if I expand, I'm going to get x squared. So that x squared, I've got a minus 8x, and then minus 4x, and then we have a plus 32. Close the bracket. If I simplify inside the bracket, I'm going to have an x squared, a minus 12x, and plus 32. And then multiply the 2 through, I'm going to have 2x squared minus 24x. Two groups of 32 would be a 64, so plus 64. If I compare that to equation number 3, yep, it's equal to equation number 3. So therefore, if I were to put them all into Desmos, they're going to lie on top of each other. These 3 quadratic functions all represent the same one. Functions all represent the same parabola. So hopefully that helps. And that should remind you of the very first lesson that we did, 4.1, where you were putting a whole bunch of different versions in. If you looked at those 3 tables, all were identical. It's just we wrote the functions in different formats. All represent the same parabola. So here is one way that we can get them to show that they're all the same algebraically. Okay.